Good morning, class. Good morning again. So, welcome to today's session, whereby we're going to have a small online session about this topic of networking. There's a section of medium access control, which I want us to look together into it. So, welcome and enjoy your time. Also, I want to point out the reason why we are having this session is because, first of all, is to supplement what we are doing in class. Another thing is I've seen that we need to put more effort in these protocols, especially the one which we are covering in local area networks, for us to continue with the rest of the topic, with the rest of the syllabus. So welcome again. If you have any question or concern, you can always reach me through my number for any feedback concerning this session. So at the end of this subtopic, which we are going to cover in 2 sessions, you should be able to explain medium access control methods, that is polling, contention, carrier sense multiple access, carrier sense multiple access with collision avoidance, and then token ring. So those are the learning outcomes which we are supposed to cover at the end of this subtopic. Remember, this topic is very, very important. It's a topic which is most examinable, and also it's a foundation to the networking world. So you might be asking yourself, what is this medium access control? So it's a protocol which defines how multiple devices share a common communication medium without interfering with each other. So remember here, if I have more than one device connected to the network, most of the time you find out that the devices are going to compete for the resources, and also because they are blind to each other when they are connected to the network, most probably during the initial communication phase, they will not know who is supposed to talk. So if they talk all of them at the same time, the way I told you when we were discussing the same thing in class, I told you that when 2 devices talk at the same time, we are going to have this called collision. Collision is whereby the packets are going to collide in the medium, and there is high chances they will get destroyed. They will not be any useful to the sender or to the receiver. So now that's why we have to have medium access control to manage how these devices share the network. So the goal is to maximize efficiency, minimize collisions, and ensure fairness. When multiple devices share a common communication medium, the big challenge is who gets to talk and when. This is the role of the medium access control, to coordinate access to that transmission, are efficient, fair, and reliable. So I told you again that remember, this is going to be manifested if they are sharing a resource like a storage. Let's say we have several computers, even thousands of computers are connected to the network to share a storage. So this storage is going to be located inside a server, and this server is also going to be part of the networking device. So remember, all these devices will want to access the same server at any given time. And if we cannot have a way of managing how they access the network or the server, we are going to have collision, and none of them is going to get any meaningful data from the server. And that's the issue. It's a very big issue. So how do we deal with that problem? We have to come up with a protocol which is going to govern how they speak and when they speak to the network, and that is medium access control. So MAC protocols have been categorized into 3 broad categories, and these are random access protocols, control access protocols, and channelization protocols. Under random access protocols, they are simple to implement, but they are not robust. So we have what is called Aloha, we have CSMA, we have CSMA stroke CD, and then we have CSMA stroke CA. So remember, these are easy to implement, and we are going to cover under this subtopic. We are going to cover the bottom three, the CSMA, CD stroke CA. And then we have multiple access protocols under control access protocols, and these are reservation, polling, and token passing. So we are going to focus with polling and token passing. So channelization protocols, we have FDMA, we have TDMA, and then we have CDMA. So remember, these are the same protocols which we discussed under the satellite communication system. Remember, under satellite communication system, we realized that we have a very wide band of 500 MHz. And how are we going to utilize that band is by breaking down that broadband into an equivalent of around 12 channels. So those 12 channels each were about 36 MHz. So how do we come up with those channels? We have to use what is called channelization protocols, and this one are FDMA or TDMA or CDMA. So this is frequency division multiple access, time division multiple access, and then this is the one which we are going to cover under our discussion later on. Now, under random access, where stations compete for the medium and collisions are resolved after they are happened. So in random access, devices are going to compete. The devices are going to send their packets whenever they feel that the medium is idle. But now, if the collision happens, we are going to solve that issue, but we are not going to solve the issue before collision happens. So it must happen, the packets must collide for us now to come up with what? A mechanism to resolve that issue. Then control access, that is reservation based, where access is orderly and coordinated, eliminating collisions but adding some overhead. So here we are going, before you actually send, we allow the station to send, we are going to control their access to the medium. So if the medium is busy, we are not going to allow them to send, they have to wait. So there, you remember the first one, they had to send. If collision occurs, we deal with the issue. Here we have to control how they access the medium to avoid that collision. And then channelization, this is a fixed allocation where the channel is divided into fixed portion, that is either based on time, based on frequency, or code. So when we are talking about code, is the last one, CDMA, and each station gets a guaranteed share. So you remember, under the 12 channels, which were 36 MHz under the satellite communication system, each channel was guaranteed 36 MHz, and that one was there dedicated, whether the network is busy or not. So I think you now get it. So we are going to use this simple network setup, whereby we have a network switch and our computers here. We have a total of 6 computers connected to this local area network. Now, remember, all these devices at any given time, they will be sharing or they will be exchanging data. And when that occurs, there is high chances that 2 or more devices will be communicating to one device at a time. Let's say, for example, you might find out that actually the computer 6 wants to communicate to computer 4, and at the same time computer 1 wants to communicate to computer 4. So if that is going to be the situation, there is high chances their packets will collide when they are transmitted to computer 4. So if these two packets meet in this medium here, we say there is a collision, and if that collision occurs, that packet will be destroyed. Now, how does random access solve this issue? How do we solve this issue using random access? To solve this issue using random access, no station is superior to another station, and none is assigned control over another. So none of them, first of all, are superior. All these computers are going to be the same, and none of them has a control over another one. We are going to see that is an issue also. At each instance, a station that has data to send uses a procedure defined by the protocol. We are going to see what is this procedure which is defined to make a decision on whether or not to send. This decision depends on the state of the medium, and this one is going to depend whether the medium is idle or what, busy. In other words, each station can transmit when it desires under the condition that it follows the predefined procedure, including testing the state of the medium. So we are going to see there are some procedures which are going to be followed of, for example, when to speak, either computer 1 or computer 6, when to speak. Did collision occur, for example, among other things. So we are going to see what are they. So what we have to know about random access is that transmission is random among the stations. That is why these methods are called random access. Stations compete with one another to access the medium. So that is why these methods are also called contention methods. So if more than one station tries to send, there is an access conflict collusion, and the frames will be either destroyed or modified. I told you if computer 6 and computer 1 wants to communicate to computer 4, and this happens at the same time, we are going to have a collision. And if this the collision occurs, so we are going to destroy either the packet which they send, and here we are talking about the frame, or modified it. Now, what are we supposed to do when it comes to this situation? What are we supposed to do if collision has occurred? Now, when it comes to random access method, to avoid access conflict or to resolve it when it happens, each station follows a procedure that answers the following questions. So these are the procedures which is going to be followed by either computer 6 or computer 1 before transmitting. So the first the first question is, when can the station access the medium? So when can I access the medium? What can the station do if the medium is busy? So if I want to access the medium and the medium is busy, what am I supposed to do? What can I do? How can the station determine the success or failure of the transmission? So if it happens that I've sent the packet, how will I know that the transmission actually was successful or collision occurred? Then what can the station do if there is an access conflict? So for example, now collision has occurred. What are you supposed to do next? Those are the questions which the device should always ask itself before transmitting. So the random access methods have evolved from a very interesting protocol known as ALOA. So the ALOA was the first protocol which was used under the random access method, which used a very simple procedure called multiple access, MA. The method was improved with the addition of a procedure that forces the station to sense the medium before transmitting. So you see here, now the first version of the protocol was the multiple access, which was under ALOA, but it was later improved by forcing the station. Before the station transmits, you have to sense first of all if the medium is busy. Now, this was called carrier sense multiple access. So the carrier sense multiple access, that is CSMA, was later on introduced after the ALOA was not efficient. Remember, ALOA was just allowing just devices to send packets randomly, and if that packets collide with other packets in the medium, then the devices they were supposed to retransmit. But in CSMA, this one was improved because a device, before sending a packet, it was forced to sense if the medium is busy. So before 6 or 1 transmit, first of all they have to sense if the medium is busy. If the medium is busy, they have to wait for a given period of time, or the duration, the predefined duration. Now later on, the method evolved into 2 parallel methods. So we had 2 parallel methods: the carrier sense multiple access with the collision detection, and then carrier sense multiple access with collision avoidance. So the collision avoidance and the collision detection, we are going to see these 2 major protocols. They are being used in the 2 major technologies we are using. For example, one is the Ethernet and the other one is wireless Ethernet, Wi-Fi. So now, according to our syllabus, we are not supposed to discuss ALOA, so we'll go straight to CSMA. So carrier sense multiple access. So to minimize the chance of collision and therefore increase the performance, the CSMA method was developed. The chance of collision can be reduced if a station senses the medium before trying to use it. Carrier sense multiple access requires that each station first listen to the medium or check state of the medium before sending. In other words, CSMA is based on the principle sense before transit, sense before transmit, or listen before talk. Now, if we are saying in the CSMA, so before computer 1 decide either to send a packet or computer 5 to send a packet, which is going to collide, there's high chances they will collide. What they are going to do, first of all, they have to sense if the medium is busy. So each station first listen. So you listen before you talk. CSMA can reduce the possibility of collision, but it cannot eliminate it. The possibility of collision still exists because of the propagation delay. Propagation delay is the time which the packet takes to travel from the sender to the receiver, and the sender to receive an acknowledgement maybe that the packet has arrived. But most of the time, just understand this is the time which it takes for this packet to travel. So for example, in this case, from computer 1 to computer 4, that is propagation time. Now the issue of propagation time is that when this one is sending and this one is sending, and the first somehow this one sensed the medium was idle and decided to send this packet. At that instant time also, computer 5 sensed the medium was idle and also sent the packet. Now, when you try to sense if the medium is idle or busy, first of all you have to send some packet that is listening. It's like echo. You must send some vibration or some idle signal or an empty signal. We normally say this is an header. So when you transmit that header, and that header you receive a signal that there's no collision in your first header, so you do now the transmission part. Now the problem is that header which you send in the initial phase is going to take time to travel down the medium, and that is what is called propagation time. Now propagation time is going to cause out what is called a delay. We are going to have a delay, and that delay is going to cause computer 5 to assume that the medium is idle. Yet it's not true. It's only that the acknowledge message took time to travel back to computer. So CSMA can reduce the possibility of collision, but it cannot eliminate it. That is true. The possibility of collision still exists because of propagation delay. When a station sends a frame, it still takes time, that is, although very short, for the first bit to reach every station and for every station to sense it. In other words, a station may sense the medium and find it idle only because the first bit sent by another station has not yet been received. That is a very critical problem. It's a very big problem when it comes to CSMA. And that's why we have collision avoidance and collision detection, which are different versions of what? CSMA. So we've seen the propagation time is going to cause a delay, and that delay is going to be called propagation delay. And that moment, it's very critical because our medium is at vulnerable time. So what is our vulnerable time? So the vulnerable time for CSMA is the propagation time, TP. This is the time needed for a signal to propagate from one end of the medium to the other. When a station sends a frame and any other station tries to send a frame during this time, a collision will result. So that is just the delay, the time which the packet is going to take to propagate down the network. And that time, during that time, this computer must assume, if this one was the computer which was transmitting, first of all, it will send a sensing packet to listen for the medium if the medium is busy. It's like saying hello, hello. So if no one answers, then it means that the medium is idle, so you can use it. But now the problem is, when you are talking, that packet will take time, and by the time it reaches you, you'll not know if the medium was idle or busy because it has taken some delay. And that is an issue because you might decide to do transmission. Yeah, so you've said hello, hello, but you are not receiving the feedback. In real sense, the feedback might be traveling back to you, but it is taking a longer period of time, and you will assume that the medium is idle and you will start transmitting. So collision will occur. That is called vulnerable time. Now, if the channel is busy, so you've tried to sense the medium, but the medium is busy. So what are you supposed to do? Now, there are some methods which we are supposed to use under the CSMA, and these methods are 3. So we have these are under persistent methods. So there's a way whereby if you fail to if you listen and the medium is busy, so you have to try again. So you have to try again and again and again and again. So that is called persistent methods. You have to persist. Now, what should a station do if the channel is busy? What should a station do if the channel is idle? 3 methods have been devised to answer these questions. So the first one is one persistent method, the other one is not persistent method, and the P persistent method. So in the first one persistent method, this whereby the station first of all is going to listen if the medium is busy. So it will send some signal at first to listen if the medium is busy. If the medium is busy, it's going to wait for a random time and then transmit. So it's called one persistent. So you try and then you wait and then you enter. So there's high chances that still the medium might be busy, but at least you've sensed. So this one is the simplest. And then non-persistent is whereby you sense if the medium is busy. If it is busy, you wait for a given period of time, you sense again. Now, whether it is busy or not, you will not sense again. You will just wait for a given period of time and then you transmit. So you sense again. So first of all, it's like you sense it's busy. You sense again, whether it's busy or not, you just wait and then you transmit. Now, let's say you sense the first time it's busy. You sense the second time it's busy. You just wait for a given period of time and then you transmit, hoping that collusion will not occur. So you see the first method and second method. The second method is actually more foolproof because the first method you just sense, you wait for the time and then you transmit. This one you sense again, then you transmit. And then the third one, which is be persistent. So this one is actually better. So you sense, first of all, if the medium is busy, there's a repetition time which you are going to use. So this repetition time is always less than the propagation time. So propagation time is the time which the frame is going to take to travel down the medium. Now, so you will sense, then you will sense again, remembering that you repeat again, maintaining the status that repetition time should always be less than the propagation time. So if the propagation time is 3 seconds, so you sense every 2 seconds. So you sense again. You are going to get a feedback if the medium is busy. You sense again. If the medium is not busy, you will not get a feedback. But you don't transmit. You send if now you are not going to get any signal. That is the reply from the medium. So if you are not going to get a reply here, then you transmit. So I think those are the 3 persistent methods whereby the station is going to sense if the medium is busy, and if it's busy, these are the things which is going to be taken. If not, then the device is going to transmit. So you've seen we have the persistent. You just try once to sense the medium and then you transmit. You don't know if it's still busy or not. You just transmit. There is high chances collusion will occur. Here you sense. If it is busy, you wait again. You sense. Now you transmit. So you'll transmit whether the medium is busy or not. You'll just wait for a given period of time and then transmit. So this one is almost foolproof. You'll sense if the medium is busy. You'll wait for the repetition time to send another signal. If the medium is busy, you will get a reply. So you will send again. You wait for the repetition time. You send again. If the medium is not busy, you will not reply. You will not get a reply. If you will not get a reply, you just wait for a given period of time and then you transmit. So this one you are trying to avoid what is called collusion as much as possible. Here, repetition time is going to be less than the propagation time. So that marks the end of today's discussion, gentlemen and ladies. So let us go through the summary of what we've covered today. So we've seen, actually we have many forms of protocols which have been devised to handle access to a shared link. We categorize them into 3 groups: random access protocols, which we've just covered, control access protocols, and channelization protocols. In random access or contention methods, no station is superior to another station, and none is assigned the control over another. Remember, this also includes network switch. None of them has a control over the other. To minimize the chance of collusion and therefore increase the performance, the CSMA method was developed. The chance of collusion can be reduced if a station senses the medium before trying to use it. Carrier sense multiple access CSMA requires that each station first listen to the medium before sending. So this is a good and a very important topic for us to understand how devices are going to access the medium, and if the medium is busy, what are they supposed to do before retransmitting again. So today we've looked at one of the methods under the random access protocols, where we've seen the devices must sense first of all the network, and if the network is busy, they have to wait for a given duration of time. That is called persistent. So you wait and then you try again. So we've looked at different persistent methods. So we have one persistent, whereby you just sense if it is busy, wait for a given period of time, and then you transmit. And then we have the be persistent, whereby you sense the medium. If the medium is busy, you wait for the repetition time, you repeat again, and then if the medium is busy, you're going to get a reply. You try again. If the medium is not busy, you will not get a reply, and then you just wait for a given period of time and then you transmit. So if you look at those methods, whereby we call them what? Persistent methods. So we are going to continue with this session in our next discussion under the networking. So enjoy your day, and please, I'm going to share the PowerPoint. Make sure you write some short notes on this topic.